So I'm going to start with discovery, then move over to mapping, and then even if time allows me, I'll show you a little bit about the migration itself, which is why I've got HCX also open. But let's start with applications first. To vRealize, applications is not really something very special. It's just a workload, a construct made up of workloads and tiers that are hosting that application. Could be a VM, could be a physical server. So if you've got a physical SQL server or something like that, it'll also be able to show that up. Or Kubernetes services. So if you have a hybrid application, which could happen if you're in the progress of transforming that app, you could have a mix and match of these different types of members within the application construct. And that's basically it. So to get that application construct within vRealize, you can manually add them, but that's no fun. So you can also discover them. We have multiple ways of getting those applications into vRealize. One of them is tag-based discovery, so we can look at tags within that are attached to the VMs, for example. So if you have an automation system like vRealize automation, it tends to add tags to the deployed VMs that it deploys. With the application name or the T name, and then you can grab those from those VMs. And it could be a vSphere VM, or it could also be an AWS native tag. We could pull it down from ServiceNow. So if you have a CMDB, sort of up to date, maybe accurate, you can pull it down as well. We can also do it based on a naming convention. So if the application name or the T name is within the VM name itself, we can pull it from there. And then we can use a different combination of all of the above. So just to show this real quickly, how this looks is I can enter a tag name and it'll discover these from the infrastructure itself. So I've added the vCenters, I've added the NSX managers optionally that are hosting this environment, and then it'll give me all of the options that are in there. Of course, these are all already pre-populated, so I don't have to type that much. So one tag for the application name, one tag for the tier name, and then I can hit discover, and it'll look into that infrastructure and then classify those VMs as an application. So this is part of a migration demo.
Show us what the available scopes would be.
Sure. So these would be like I can discover it based off all of the VMs, or I can select on a specific like scope of VMs, like one vCenter or one VPC. Like there's a lot of options over here. I can even just look at one IP range or one OS. Yeah, there's a lot of options there. So I've already saved these ones, so they're a little bit grayed out, but these are a part of a demo where we've already formed migration waves, as we like to refer them to. And then one of them is a production tier with 3 VMs in there, and then automatically those VMs get placed into that migration wave application if you save them. So that's one way that we can do it. The other way is a little bit less involved even. And let me go, no, let's not. So I could go back and restart the discovery, look at the scope again, but then also give this algorithm a naming convention. And the reason why I'm saying algorithm is because flows-based application discovery is what is behind this. And this looks just at the network traffic that goes through the network and then correlates application boundaries based off of the application traffic that it sees. So it uses a machine learning algorithm in order to correlate the VMs that it's seeing and then create a sort of a virtual network chart within vRealize itself. And then based off of that network chart, it knows what talk to what, but also how much does it talk to each other. And based off of that, it'll recommend an application boundary. So if I very rudimentarily look at this one, this is a two-tiered application where we've got a front end and a MySQL server, and it's named it's a prod application because prod is a common thing within these VM names. But it is suggesting this because there's traffic flowing through this application, and it also knows that the front end is talking to the MySQL server, which is why it's putting these two into different tiers. So I don't have to do anything basically to get this running. I just have to implement vRealize, make sure that the flows are flowing and being collected. And then I can just run the discovery and get this far.
If it's not running on a VM, like does everything have to be on a VM inside of VMware for this to work, or do you have plugins to other systems that look at flow information in case it's one component of the application is running on a bare metal server somewhere inside your data center? Like what kind of integrations do you have there?
Yeah, so right now I'm always referring to VM, and people kind of correlate that to vSphere VMs, but within vRealize, a VM is sort of a container for all the VMs that we know, and all of the VMs that we know are vSphere VMs obviously, but also EC2 instances within AWS and Azure VM. So anything that's virtualized that we can discover in either public cloud or on-prem is already taken into consideration with this. And then when it comes to bare metal services, we can definitely discover them, but they are currently not yet placed automatically within these applications that we're discovering using flow-based application discovery. But we can add them later on because you can manually edit these applications as well. Add a physical IP address or a range that could also work, and then save that, and then we can do the work on that application construct. We're looking into ways to get that IP address into the discovery directly. But one thing to note is that vRealize is an absolutely agentless solution. And that's our philosophy as well. So we do not want to be installing agents anywhere for this to work, because that kind of like trumps the effort needed to get this running and the actual value of the discovery, because this discovers things that you probably didn't even know about, like SaaS mentioned that customer didn't know what they actually had running. And well, you need to know what you have running before you can install an agent. So that's kind of the reason why.
No, that makes perfect sense. And even agentless, that's why I was wondering if it would take in like NetFlow or IPFix or SFlow, JFlow type information at all.
Yeah, we do that. But that information is not processed within this application discovery yet. That's what I'm saying. But we are ingesting, or we are able to ingest that information. So you can just send your NetFlow or SFlow from the top of rack switch to vRealize, and then the flows will also become visible within vRealize. Actually, let me open up this one. Yeah, here we go. So we got one physical. All right, let me back up a little bit. This is our security planner, which is kind of dubbed the dependency mapper as well when it comes to the migration context, because we can group by application, for example, and then see what that application is talking to. And I've got these waves over here, which are representing that migration wave. But then I can also see what types of communication do they have. So I've sticked this one, but as you can see, it has more communication than wave 3 and wave 2. But if I then look at this one, I can tell exactly what is talking towards that physical endpoint. So I've got the port number, the amount of flows, and the amount of traffic that goes towards that physical endpoint. So I know exactly where what is going, and then I can even drill down deeper and see the actual chart, the graph, the network graph that this is occupying, but that won't be that interesting because this is very little traffic.
Is there
So this is
some way to actually take the output of this and feed it into NSX firewall rules?
Yep. This is a little bit underwhelming because I'm just showing one flow with one type of connection. But for every single slice, every single connection, we have these recommended firewall rules. And these are basically translations of the traffic that we're seeing into the standard firewall rule syntax that you know and love. And these can be exported both to CSV. So if you want to import it to somewhere else, like a physical firewall, that could also work. But this XML format is actually NSX compatible format. So I could export this XML and then import that into NSX, relatively simple. And let me actually get.
Is there a plan to make some sort of automated way so you don't actually need to do like a copy and paste?
There is there's two things that kind of. Let me open this. Yeah, this is a little bit more impressive. But
Martin, if I can jump in, I'm a bit confused because we were talking about vRealize Network Insight Universal. I know we're seeing that you're in vRealize Network Insight Cloud. Is this just a management interface, or is this a different product?
I'm gonna back up a little bit. Like vRealize Network Insight Universal is basically just a license model. So that's the licensing model that SaaS explained a little bit earlier, where you can be flexible in what types of deployments you have. Mm-hmm. So I'm currently looking at indeed a vRealize Network Insight Cloud console. Mm-hmm. If I open this one, I've got an on-prem instance, which I was gonna show in a bit. But they are reporting up to this same VRNI cloud instance, which is licensed as a universal instance, meaning that I've got that flexibility with the licensing scheme. But when it comes to the actual product, we've just got two versions of it. That's the cloud, the SaaS model, and the on-prem model. Okay. And even then, both products are exactly the same. So we don't really have a difference in features and functionality between the cloud version and the on-prem version. Mm-hmm. It's just that the cloud version has that federation feature that Seth also mentioned.
Okay, thank you.
Then coming back to the other question about automating this, there are already ways to automate this, and you definitely don't have to copy and paste this. So I don't think I'll have time, but as a sneak preview, I was going to show CodeStream, which is our pipeline product within the automation suite. And we've got it set up in a way that we are actually automating that entire process. So we do have a script available that you can use in order to read in this XML export and then automatically input that into NSXT or VMware Cloud and AWS, because that's also run by NSXT.
Okay, I didn't need a demo, just the yes, no was all I was after.
Yeah, okay. So there are ways, yeah.
Okay, cool. I mean, I'm sure you can do it with a script.
So to Martijn's point, as the migration waves happen, he showed the wave of an application, but part of the one of the step 3 in that arc was that security part as well, right? So what they do is take those firewall rules that we recommend, and then they use those scripts that Martijn talked about to complete the destination firewalling as well. So again, that's the idea behind all this, right? We have recommended the apps, we have recommended the firewall rules, go for it. We'll now go secure the destination. Okay. I think somebody on the chat asked about, hey, we have VRA, I have VROps. This is a beautiful way of actually bringing all these products together. Martijn talked about CodeStream. That's out of the VRA family of products, right? And then here's Vernie. So again, we work in conjunction to make the experience for the customer better. Sorry, Martijn, back to you.
That's basically exactly what I was going to say. Like everything that you see here is available via an API, and those can be strung together in whatever shape or form you would like, basically. All right. So while I'm here, we've already talked a little bit about the application dependency mapping. So this one actually indicates a perfect migration wave because they're not talking to anything other between them, right? So they don't have any communication between each other. They're just talking towards the internet and some shared services. And we've kind of already seen that, like the data that is going over those is not that big. I mean, just a little bit of internet traffic, mostly going over HTTP and some NTP traffic, etc. So these are actually ideal migration waves candidates. The place where it gets interesting when you do see those interconnectivities. Then you can use that same data that I showed you with the internet traffic exactly to show like what type of capacity does my data center interconnect need to have, for example. So if I'm moving it somewhere else, I need to make sure that those connections are capable enough to handle that traffic. Let's see where I'm gonna go. I'm gonna go here. So this is an application dashboard which can be used for multiple things. One of them is to troubleshoot the application itself, and then Veer and I will go in and check all the surrounding devices, host, top of rack switches, see if there's any errors. And well, as you can see, there's a ton of errors on this one. So you can do troubleshooting. You can do just looking at what the topology is of this application. So it's a very neatly organized topology where the web server talks to the app and then the app to the database. I can discern. Go ahead.
I'm just curious on this type of view. We see these in all sorts of apps. When you go in to troubleshoot it, you're looking at it and you're seeing the current state. Do you have a way to show it over time so we can see what may be changed to cause the problem?
Yep. For example, I can go back in time, and if I click this one, I'm not going to do it. It'll also represent the topology in that point in time. But as you can see over here as well, there's like a ton of alerts that are going on a specific time. So these are all alerts, I should say, by the way, because they're orange, but we also have configuration change events. So for example, if a switch has changed or a VM's configuration has changed, or even like an NSX networking configuration, that would pop in this timeline as a change. And then you can also see what has been changed, like has the VM been downgraded in resources, or is there a new security group added? Those type of things will also be visible. So yeah, you can pretty simply and easily get to the post and the pre-state of an alert or of a change, for example. That's there. So this topology, like, it discerns all of these things. We have the top of rack switches. I can zoom in on the actual top of rack switch. Like in this case, this is Cisco Nexus switch, which again, a ton of alerts open. And like just to give you a hint of like what we're checking, but they're really networking heavy things like configuration mismatches. That we are looking at specific LLDP information, STP. Yeah, spanning tree is still a thing these days, unfortunately. But there's a lot of this information that gets just processed into the application view, right? We also have the load balancer information right here. Things like what service pools are being used, are there any flows going through that application or the load balancer, and then what is the configuration of that load balancer itself. So this is an NSX advanced load balancer, or the artist previously known as Avi. And again, you can see the entire configuration, like which engines are powering that load balancer. Is it up or not? Kind of important to know. So it can be used for multiple things like troubleshooting, but also just knowing like what the topology is like. So this is sort of a double check, maybe a triple check of how that application actually looks before you start touching it, because it comes from the actual infrastructure. Right, let me switch to that federation dashboard, where I am in a vRealize Network Insight cloud instance, because that's the one feature that's just available in cloud. And I have this federation dashboard, which you previously also saw in the as a screenshot, but seeing it live is also always a little bit better. So we have these, how many are there? 6 vRealize instances, all of them hosting something else. So they could be either just hosting. All of them are monitoring something else. So they could either be just monitoring AWS or on-prem environments with NSX and vCenter, or they could be monitoring VMC and AWS. Like any of these types of environments, we can monitor and we can drill down onto. But basically, we're just saying, like, are there any critical problems within these environments? And this is also where that data governance comes into play, because we're showing like how many VMs have critical problems or other problems. And then to get to the root of those issues, we can open the instance, the vRealize instance, and then be catapulted into that specific vRealize instance to look a little bit further. Yep. And then like this also gets translated to this map, where you can see that all across the world we have problems. And just in this region, we just have one vRealize cloud that is behaving pretty well, all green. Okay, so there's a lot more to zoom in here, but I'm gonna save you from going through all of those. But basically, this is your overarching view of the entire environment in a sort of a bird's eye view. And then if you want to zoom into any of these alerts, I could go to Palo Alto, get the critical alerts, and then dive into that instance itself to see what's actually going on. And same for the network traffic and all the applications that are residing within that environment.
Good. So here's an example, right? So a customer started this journey, and their journey is migration, and migration are from a variety of sources to the cloud. Let's say they have 6 data centers, and Martijn showed the 6 vRealize instances that they want to monitor. They start off this as the baseline, and then we've started up applications, 103 applications. Small number, but let's assume they have thousands. Now, the end state, 12 months out, 18 months out, is to collapse this down into 2 data centers / VMware Cloud on AWS. And the applications have to go from 1,000 to 400 because some of them are going to be abandoned. This is a great way to keep tab of that, right? You're shrinking the number of data centers, and then you're also seeing the number of applications migrating. So here's a good example of all the applications in the various data centers. Now, again, I'll give you an example. So the goal is to get into, let's say, Sydney and US vRealize Cloud. Those are the 2 destinations, and everything else needs to be shut down in a month, 12 months, 18 months time. This is a great way to know. Otherwise, you're going to hopping around different dashboards to find out, hey, am I migrating right? Am I on pace, not on pace, et cetera, et cetera. That's why this federated view provides that good way to complete your migration as well. And as you can keep tab on how are we doing on time if there's an audit thing. Again, the goal to the customers and users are choose your cloud. What is your destination, right? Destination could be to another data center, high capacity data center, or your VMware in cloud or native cloud. That's your first choice. Then use this to accelerate your migration and modernization, right? You look at the federated views. Now, the final thing is the flexibility, right? Because you don't want to be paying the same sockets multiple times. This allows you the flexibility of the licensing part. That's it. That's pretty much the gist of what we wanted to talk about today. vRealize Universal gets the customers there rather than looking at them as individual hotspots in individual areas without getting a single pane of view.